Good morning. How are y'all doing?
We're doing well, doing really well.
Good. It feels like nighttime, doesn't it?
It
It
does.
is,
So weird.
it is really, really strange.
Oh gosh, yeah,
You know,
Avea is
look
just
around at Ivea's place there.
yeah. Ours is not quite as red, but it is. It's just as strange.
It was difficult to try to capture the color.
Yeah, I know.
Yeah, I made some little boxes, and the but I would. It makes me want to have a. Oh, nice. Is this on a time
Oh,
scale?
great.
Oh no, sadly no. It was just me trying to get the color and failing repeatedly until I finally figured it out that it was this one. It, it,
Wow.
it was hard to get the exact mix because it had a degree of pink in it that I couldn't
Hmm.
capture. I don't know if anybody's seen Avengers Infinity War, but I woke
Hmm.
up thinking that we wound up in the Soul Stone.
Yeah.
And I was like, oh God, if I see Gamora and Thanos walking around here, I'm
Yeah,
gonna hug Gamora. So
yeah. The this is really, really strange times. I kind of feel like we're getting a rather clear message from the planet right now.
Hmm.
Yeah, for folks who aren't uh, kind of calling in from the San Francisco Bay Area, if you take a look at Vea's video here, let's see. I'm gonna pin you. Actually, no, just stay right where you are. What I want folks to notice is just how dark it is here. This is full daytime here in the Bay Area. In my room here, if I turn off the lights in the middle of the day, isn't that crazy?
wow.
You know, we're and she's recorded the color of the sky here.
You can't see it
And
very well, but also an experiment I'm doing. Um, I took an old, my son sometimes eats Pringles, so I took one of the caps, cleaned it off, put a teeny, teeny bit of petroleum jelly in it, because I don't usually use the stuff, and put it outside so it could act as a little catcher for all of the particles falling down. And right now, there's no wind out there. So what I'm gonna do is wait for the temperature to rise up and for the wind to begin, and then I'm going to switch it out with another one, because right now, they say that we're being protected by the marine inversion layer, where it's this lovely cold air that's
Mm.
protecting us from all of the soot falling on us. And so
Wow.
once the wind begins and once the temperature begins to stir things up, then all of that lovely stuff up there might descend. So then once I do that, I'm going to put out another collection tray and compare the two just for
oh,
funsies. And then I'll journal about it.
That's cool.
oh boy,
I was thinking that the smoke must be high because I don't smell it in the air. But
yeah.
yesterday, I've been watching this garden spider, and I watched it make this beautiful orb net web that I drew yesterday morning. And at the end of the day, it was broken and covered with little bits of ash. And I thought, oh, that's strange. That was yesterday. And then this morning, I go out and it's like so smoky. So, yeah, it's really interesting. So, I'll have to go out and see if I can catch some ash too.
And even now, even with the inversion layer protecting us, there's still little bits of ash. Like, I'm sure people have noticed that electronics catch dust really, really well. So I took a broken one and cleaned it off real carefully and just put it on the front porch next to me for 20 minutes or so. And it was already beginning to catch little bits that were coming through the inversion layer, little bits of soot.
Oh, wow. This is um, well, it's an interesting observable phenomenon, isn't it?
Yeah, that's for sure.
That I just sort of feel like I'm on a planet that's screaming for help and saying, please listen to your youth.
Yes.
And people with power to kind of engage on this and do something about it.
Hmm.
Let's get busy, gang. This
Yeah.
is profound.
And helping our
Um,
students observe this phenomenon and then, make sense of it and not be scared, but just to watch it with curiosity and pull out your nature journals, just like Ave and others are doing, and just be curious and see what we learn. We don't have to have the experts telling us, the specifics of what's going on, although that can become interesting, but like really first starting with having a pencil and a piece of paper and your eyes and senses. Anyone can do that. And you guys, as educators, you can all do this.
Actually, you're
We
making me
can all
wonder.
do this.
you're making me wonder something. For Wild Wonder, are any of the sessions going to be talking about nature journaling and stewardship, or about like stuff that's like just all of this and how we capture it? I have to check the schedule, but I'm just wondering if that's going to be one of the sessions.
That if it's not, that
Great idea.
That's a beautiful idea. Yeah. That would be a really profound and important session. So the part of what we're asking students to do when we're nature journaling is to observe carefully, look for evidence, and wonder and ask questions. And you can't help but then start to kind of bump up against what's going on out there. What's going on with fire frequency? What is going on with, if we are asking people to look at evidence and to use evidence as a tool for decision making, it puts us right in the middle of looking at climate change and all the related phenomena. Sorry about this. Silence my phone and turn it on to very, very quiet mode. Very, very quiet mode. There you are. This is relevant, and it's unfortunate that climate change has become a political football, and if you look at the arguments and discussion around, some people are saying that you shouldn't be teaching it in school. And it's interesting to kind of break down and analyze those arguments. A lot of what we see we come up against a really wonderful opportunity to teach about the processes of science and how we figure things out. You'll hear a lot of people talking about, scientists, give me one piece of, people say, give me one piece of evidence that can prove that climate change is real. And there are other people that see climate change is going on, and then they say, give me one piece of evidence that proves that it is anthropogenic or caused by human beings. And when you hear those sorts of statements, what you're encountering is a fundamental misunderstanding about what science is and how it works. The term proof and prove are terms of mathematics. You do a proof in geometry. You do not do a proof in science. Scientists don't do proofs. What the reason for this is that when we're doing math, what you start off doing is you write out the rules for your mathematical system. So if you're doing Euclidean geometry, here are the rules for Euclidean geometry: parallel lines that don't meet, and it's on this flat surface, and you can figure out the rules of Euclidean geometry. And then based on that, you can do proofs where you say, if all these things are true, and this is all that's going on, therefore, whatever result you're getting. The difference is with science and understanding the physical world around us is that we don't have the rule book. We're trying to figure out the rules of the system by sitting within the system and looking out and observing its behavior. And the result of this is that we cannot do a proof. What we can do is we can look at a bunch of evidence and we can say, wow, it points towards this. And you can even take it further, that you're saying, if this explanation is true, I would expect to see these different things. And if I don't see those things, then whatever explanation I'm looking at is probably not correct. And so what we do with this system is we get, and sometimes we'll test something, we're like, well, I'm not finding these things. And so you kind of change your explanation a little bit. And then you go back in and you can test it again. And what you get is you slowly change your understanding of something over time and incrementally get a little bit closer and a little bit closer and a little bit closer to an understanding of what's going on. But we're also acknowledging that we're never actually going to get there. But doing this process, you can get very, very functional, very, very useful, very predictive explanations of the way that the world works around you. And that allows us to, that's the reason why things like this work, right? It's based on our understanding of electromagnetism and gravitation. Gravitation is a theory and we don't really understand it all the way, but our understanding is good enough that we can launch a rocket and have a satellite go whipping around a moon and cast off into space and intersect one of the Jovian moons exactly when you planned it to. And that's pretty amazing. So you get functional stuff, but that's different than saying proof and proved. So we have to kind of approach things with humility. And that is, I believe, one of the great strengths of doing science. But when non-science people look at that language, you'll hear scientists intentionally using the language of uncertainty. That means, and so you'll hear people saying things that sound like they're just kind of being wishy-washy and mushy, right? But really what they're trying to do is be as accurate as they can in their language to put some air bars around the sort of statements that we can say when we're sitting inside the system, looking out and trying to understand the rules of the system. So you'll hear people say things like, the evidence supports this, right? Or that this explanation is really strongly predictive. I mean, that sounds really weak, but what they're saying is this explanation, you can come up with as many things as you want. That if that's true, I would expect to see this and this and this and this and this and this and this. And then we go out and we look around the universe around us and we see those things, right? If we didn't see those things, it would mean that that explanation is probably wrong. But we do see those things. It's incredibly useful. So it may be exactly what's going on. Your explanation may be right. But at this point, you're going to say, wow, that's really predictive. That's really, really useful. And so the ones that are sort of stand up to the most test, at some point, we call these a theory. And it's when we talk about a theory in science, it's different than the kind of colloquial way we have of saying, I've got a theory that cousin Ed is really a space alien. Right? So we use the term theory often to just sort of mean kind of a wild hunch about something. I've got an idea. But it actually has a very specific meaning, that it means one of these incredibly predictive, useful explanations that we've tested a million ways from Sunday. So gravitation is a theory. Gravitation is a theory. And we get it's our best understanding of what's going on, but we're not saying that it's right. And as we start to find things that are kind of part of our understanding that is off, we're going to be tweaking that and arriving incrementally at a better understanding. So like you might have an initial kind of idea of how gravitation works from Newton, and then that starts to have kind of, when you get at sort of relativistic speeds and things, it starts to fall apart. And then you know, enter Einstein, and he's going to tweak your understanding with general and special relativity. And you know, your understanding of these things, it's changing, and that's actually an asset. So in science, if you've got an idea that's dogma, that nobody is threatening, nobody is testing, nobody is challenging, it's useless. Right? So when somebody says that, you know, climate change or anthropogenic climate change, so climate change being caused and driven by human activity, nobody's proved it yet, they're right. Right? So if that, but that is that in terms of that, if we're using proof in this kind of specific way, right? Again, that's not what scientists do, but we can say that there's a huge preponderance of evidence that we're testing from all these different directions that points us towards this explanation, and that's useful. And so I recommend for educators, climate change is a really useful way for us to look at the structure of science and how we figure things out. And the sort of the idea of sort of what actions does the preponderance of evidence really point us towards. So the reason we're kind of on this subject today is because I'm calling in from California. If you look outside my window, it looks like it's night out there. That's actually smoke from fires in Northern California. And it's like nighttime out there. And so it's really got our attention. Thoughts and ideas and comments. I've been kind of launched us with a little bit of a monologue here. But I'd be interested to, as educators, what this triggers for you: thoughts, comments, ideas, extensions.
One thing, I've had a lot of thoughts while you were talking, which I appreciated just hearing all of your thought process on that, because it got me really excited. One of the things that I thought of was that you'd said that, you know, you might find something that you know, maybe it is right. Or I was thinking maybe it's that our ideas could be right some of the time, because the way things are changes. It's not always the same way things are. So we might be right some of the time, or then something else might change. And then, so it's this idea that ideas don't even have to necessarily be purely right or purely wrong. It might just depend on the time of day that you're thinking these things. Yeah. So,
yeah, you're absolutely right. So rather than thinking about it as right or wrong, think of it as being useful. Right? Here's an explanation that is useful because it's really, really predictive. And the minute it stops being predictive, it's less useful, and so we need to modify it. And we will. And anybody at any point, if they get kind of emotional attachment to one explanation and they no longer want to test it, they're stepping out of the practice of science. So we can't have sort of a pet favorite explanation and not test it. We want to, it's not right, wrong. It's, you know, how useful is this? How predictive? And that's different than the kind of the right, wrong thinking. Again, we're in the system looking out, trying to figure out its rules.
I think that you're talking about science literacy here. And I just want to thank you, Jack, for modeling an extraordinary way to talk about science, to educate non-scientists into what science is in a nutshell. You just did it beautifully. So any of you on this call, you've got to rewatch this video and just listen to how Jack explained it. There was nothing threatening. It was just simply laid out there. And I think that there's the problem we're having, well, not the problem, but some of the problem that we're having are people who aren't educated in science, don't understand exactly what Jack said. You know, the proof, give me the proof, give me the proof. When it's like you're asking science to do something that it just cannot do. It just, that's not its job. But instead of explaining that, because it's hard to explain that, you know, Jack, you just did it really beautifully just now. I took lots of notes because I'm always trying to convey this. You know, I have a science background, so I understand this. And sometimes scientists appear wishy-washy, so the public doesn't trust a scientist because a scientist cannot say this for sure and that for sure. It just is not what we can do with, so it's just, it really is a language, right? Just like Spanish or French. We use the word proof and prove and theory, especially when we say theory, it's not like this, like, you know, hocus pocus kind of guess. It really is something solid. And so your example of, you know, using gravitation, you know, as a theory and what that means in science and what that means to everybody else. Just, I think if we had this understanding about science, there would be so much more, less confusion in the world. Right. And, you know, even those of you who are not science teachers, just having this understanding as a human of this planet, as a human who takes action that's been adding to what's going on in what we're seeing today and have been seeing, is really powerful. So, you know, each of you as educators, even if it's not science, is not your main subject, you know, understanding this and being able to share it with other adults, with your family, with other students that you interact with, is so powerful. And, you know, this kind of ties back into the idea of conservation and stewardship. You know, I don't think that we have to outwardly say we have to protect this planet, but even just in the nature journaling community, teaching people how to observe nature, watch phenomenon, record phenomenon, and understand the scientific part of it, not as a complicated science person, but just from a lay person's perspective. This is what a scientist does. We observe, we record, we just ask questions, and we wonder, and we keep testing. And I think that if more people had their nature journal and observed nature in this way, we would see a different place. So, you know, each of you has tremendous power in reaching hundreds of lives, and collectively, oh my gosh, if we all went out there today and committed to learning this deeper for ourselves and sharing it with the people that we educate, we would make a huge impact. And I can feel it, right? With all of these different things that are going on in the climate, people are waking up. They're just saying, and so I think it's important for us also to not feed into the fear. People are getting scared, right? They're getting scared that something's going on, something bad's going to happen. But if we give them these tools of observing nature, and then so that they can start to get connected and care and want to be part of being a steward, I think my personal perspective is like that. I think is much more powerful and longer lasting than just having them go out and use, you know, reusable, you know, recycle, reduce, reuse, you know, that kind of thing. Although that's important, but what I'm saying is, like, you know, giving them the tools to fall in love with nature, like what nature journaling is super powerful.
You think about something like observation is a revolutionary act. That originally in medicine, what the dogma was is that you respect whatever the greats have told us, right? And that can be about the way that, you know, blood circulates. That can be about, you know, there are all these pieces of misinformation that we stuck with for centuries because, you know, well, Aristotle said this, so we're done. And then people weren't actually, you know, looking at human bodies to figure out, like, is that true, right? And so to actually make your observations and say, you know what, it seems like those little light colored objects that are going around that big light colored object, those are moons going around Jupiter out there. They're not orbiting around the Earth. There's actually things orbiting around Jupiter based on and here's my evidence for it, right? That is a subversive act. Because, it's also an incredibly empowering act because you are you control the reins then. You are making decisions that are based on evidence from the world around you. And making arguments from evidence is the most fundamental science idea. Science is about making arguments from evidence. And it actually takes practice and training in order to do it. When we, and fortunately, making arguments from evidence, it is one of the key science and engineering practices from the next generation science standards. So in school, if we're following the next generation science standards, we're teaching people about the ideas of making arguments from evidence. I was really proud of my own daughter, Amelia, the other day in a Zoom meeting in her class, in a respectful way, said to her teacher, like, "Oh, wow, that's really cool. That's really interesting. What's the evidence for that?" The statement, "What's the evidence for that?" is something that I have been teaching her for years. And it came out in a conversation with an authority figure, and she was wondering what the evidence for a statement was. And that is really, really powerful. And another kind of fun thing, if you're a school teacher, and so if you're looking at one idea that connects into the science standards, the language arts standards, Common Core, and the mathematical reasoning standards, they all have built into them this idea of making arguments from evidence. So when you are doing that, you're actually, in that one act, touching on fundamental core ideas that are present in different areas of your standards. You're bringing those together, teaching this fundamental skill.
How old is your daughter that asked her teacher that?
She's 9. Amelia, 9 years old, asked her 4th grade teacher. That's interesting, and not in a way that's like, what's the evidence for that, right? But really kind of leaning in. Wow, what's the evidence, right? I mean, asking for evidence shouldn't be a threatening statement. It should be a celebration of the, because you hear lots of statements, and different sorts of statements can have different levels of evidence behind them. Sometimes it's really, really, really strong, and there's strong, compelling evidence behind something. And but sometimes, we'll make a statement and it's based on weak evidence. And it's for us as speakers and thinkers and teachers, for us to have a handle on what are areas where the science or evidence is really strong, and what are areas where it's emerging. That's useful for our own epistemology. How do we know what we know, right? And if we're making statements and we don't know the evidence that those things are based on, we're just depending on somebody else's talking points. And we are in a place where our natural gullibility or need to be a part of a group can be used against us to get us to promote ideas that are wrong. And doing that, I believe, is dangerous. I think that the more that our understanding of things relates to the way that, the closer we can get to our understanding of the way that something works being the way that things actually work, and knowing that I'll never actually 100% get there, the closer I can get, the better off I am. would love to hear from more people on the call about your thoughts, comments, and ideas in this area. You can, on these calls, you can just unmute yourself and feel free to contribute to the conversation. And just when you are not contributing something, just to have your microphone muted so that extraneous noise in the background doesn't build up.
Jack, I have a thought.
Yes, sir.
This is Joe Coho. I I was listening to your description of Amelia talking to her teacher, and I was thinking about the incredible power teachers have to suppress and snuff children. In particular, if you are in all innocence asking, what is the evidence for that? And the teacher comes back because they are perhaps insecure and slaps you down for it.
Yeah.
The child doesn't understand that the reason why she got that kind of answer was the teacher's insecurity. Instead, she feels maybe she did something wrong. And I've seen that so many times in the course of my life. It just concerns me.
Yeah, Joe, that is a really important thought. Just think about, let's think about kind of our human psychology. A big part of my identity is the ideas that I have. And if somebody says, that's interesting, what's the evidence for that? And I start going like, and there isn't any, that's a vulnerability. That's a vulnerability. And the strongest thing that I could possibly do in that instance is to go, you know what? It's weird, but I've never really thought about that. And I don't have strong evidence, or that's based on a feeling that I have, and I don't have evidence for it. Or, you know, whatever the reason is, just to be it. But you're absolutely right that if my ideas feel like they're being challenged, I can come back and fight against that with a ferocity, because that challenging my ideas, if I identify myself with a specific idea, then that idea is challenged, I'm challenged, the idea is threatened, I'm threatened. And so I'm going to come back at you hard. You're absolutely right. I've been in some really interesting discussions with scientists about exactly this idea. And a concept that I think is really useful about kind of self-identity, and just realize that if your ideas become your identity, threats to those ideas are threats to you, and you will come back against those without reason, but with, you know, anger. So rather than have your identity, the more you can disentangle your identity from a specific idea, but to wrap your idea up in a process. The idea of the process being that I am going to try to base my opinions on evidence, and the stronger the evidence, the stronger the opinion. And I am going to be willing to change my mind in the presence of disconfirmatory evidence. And that is, it's work that we have to do. And the idea of like, can I get myself to disentangle my identity from the idea, and instead have my identity be that I will, I am, as the evidence is over here, then that's where I am. And to change my mind in the presence of other evidence. It's something that we also can train ourselves to do. It's something that we can also train our students and our children to do. And part of the way we do that is through discourse. And through engaging in conversations about this stuff, that's why the idea of an argument from evidence in these new science standards, they want to have people discussing these things. So not arguing in terms of like, right? But arguing is like, you know, this idea, grappling with this idea, and let those ideas kind of have it out. And then I'm going to watch what happens there. And I don't have a dog in the fight, but I want to watch these ideas play. And then what's going to emerge is a more useful position in understanding these ideas. You're right though. It is a real danger. And I should talk to her about, you know, at some point, somebody's going to, without evidence, is going to come back at you hard because they're scared.
Please do, because children are so wonderfully intelligent and sensitive. And the thought that they can be slapped down and take it to heart, you know, because they're merely asking a question, is a very painful thought for me. And I've actually seen it happen. I mean, it's just devastating.
I think,
yes.
Sorry, what you said really, really moved me. I think that a lot of us can probably relate to that. Either we ourselves were the children who were slapped down by people questioning us, or maybe if we haven't trained, maybe we're the ones who said something and then regretted it later. I think this is probably going to sound strange. A little disclaimer, I have some social anxiety. So sometimes I'll do something where I practice what I'm going to say in different situations. Maybe it's a tool that can be kind of useful too when it comes to talking to kids. Imagine situations where they might say something, because I think as educators, we can set that example with kids as well, that you know, they can be met with curiosity instead of with being slapped down. And so we can practice things. Like, for example, if a kid observes something that you don't, instead of immediately saying, you know, oh, I didn't see it that way or something, you could practice. You could say, oh, I didn't notice that. Could you please tell me more? And practice things to say for the kids. For example, something that my son did recently, oh, this is going to be so hard to see, isn't this? There was this math question, and I posted up on the how to teach nature journaling thing, and it asked, which of these shapes is wrong, or which of these shapes is different from the others and why? And his class was talking about the pentagon in the corner. My son immediately said the square because it's a different shade. And I'm ashamed to say that my first response was to say, oh no, but they're talking about the pentagon, till I had time to think about it. And then I said, you know what, Logan, you have a point. You're absolutely right when you said that. And I said, do you think maybe we could look and make a case for why each of them might be the right answer? But I realized that my first response had been to try to correct, and that was something I needed to change, and I apologized to him for it later. And I think it's important that you bring that up about you know, kids getting slapped down so easily, because I think that we can even create ways of addressing that and something to practice with each other. So I just wanted to say I'm really glad that you brought that up. And for those of us who have experienced that ourselves when we were younger, and even now as adults, we could think about what we would have liked to hear in that circumstance instead. So thank you.
Jack, you didn't say how Amelia's teacher responded.
I don't know. But I will find out and report back to you in the next call. I will ask her about that. And there's somebody else who is also just asking a question. First of all, Ved, what you shared there, I think was beautiful and critical and important, and it makes me taking a kind of a pause like that to think about how we teach and how we parent. That's really, really powerful. Thank you for sharing that. I really respect that.
I had always tried with my classrooms to set it up as a safe environment, so that there are ways to say I don't agree that are polite. And I was teaching 5-year-olds. And there are ways to be very disrespectful. I always try to be the teacher who said, you know, when somebody said that, to step back and say, do I have evidence of that? And say, all right, let me go find it and let's find out. Because we're all supposed to be learning, including the teacher. But yeah, that's a great thing that she did. Say, wow. So.
Yeah. Thank you. Yeah, kind of what you're talking about is those norms for communication and discourse. Learning those in school, in classroom, where we have a chance to disagree and engage with each other around ideas, and have that be in a supportive, interesting, loving way that pulls us closer towards reality and a resolution, instead of like, it's the opposite of debate, where you've got a position, I've got a position, let's see who wins in the next half hour, go, right? And just about any time that you're talking to people around political things, it quickly goes from discourse to debate, because political identity has a lot to do with our sense of self. And so if I change my mind about something political, I'm letting the team down, right? But science is such a beautiful place for practicing discourse. And you know, if you look around, if you listen to, let's say, talk radio, talking heads, or, you know, sort of aggressive pundits, they are demonstrating techniques that shut other people down and don't allow for the free exchange of ideas. They're really good at it. That's why they're syndicated, right? But the more we listen to these people, the more we can develop those same habits of speech that tear apart the fabric of fundamental communication. And so I like to listen to people not debating, but engaging, and try to look for, you know, where am I seeing kind of examples of, like, what can I take from this to kind of pull my game forward, to kind of keep me, to try to, it's hard to keep in a place where I'm willing to change my mind about something significant. But I'm now at the point where I am excited to look for the next big thing, where if I engage with somebody about, in a discussion about something, if I actually am coming at it from a place of thinking like, oh, good, like somebody said this to me a while ago, and it challenged my worldview in a wonderful way. They said, what's the last time you ever changed your mind about something that was really substantial or significant or politically connected? And I said, well, that, so ever since then, I've been looking for, like, okay, right, game on. If I'm not changing my mind about things, I'm probably not paying attention, and because it wasn't. And so now, when I kind of engage with somebody about something and we disagree, I'm thinking to myself, oh, good, this actually may be a good place for me to change my position. Maybe not completely, but maybe I'm really over here, but maybe the better position is over here. Like, so I'm looking for opportunities to move my slider and actually have that be not something that's threatening, but I want my slider to be moved in evidence. And when we are in areas of discussion and discourse that are outside of evidence, because there's a lot of discussions, things, it has nothing to do with evidence. Some things are about just, you know, belief and ethical sorts of things. In those sorts of situations, I'm trying to find things that push me more towards kindness. So I want to either, you know, on the on stuff where it's an evidence-free zone, I want to try to move more towards kindness. And in the zones where it is about evidence, I want to try to move more towards having a position that's based in evidence.
John, can I add something?
Sure.
Interesting conversation, really. I'm not from a science background, but so the points that Evia mentioned and Joe mentioned, and when you talked about identity, coming from a philosophical point of view, I think a lot of insecurities and disagreements happen because we attach ourselves to the work that we do. I mean, our work is very important to us, but I mean, if the work is taken away from us, do we still exist? I mean, I think the world is really going at a phenomenal pace. It's going too fast sometimes, more than it can cope up with things. And then do we spend even 5 minutes thinking about if everything around me just shudders, do I still live? If my name is in there, who am I, really? So that, if we answer that, I mean, I'm not trying to go to any conclusion really, but I think people spend so much less time on self-reflection. And that's when we became so much defensive about the work that we do, and that, okay, I'm a teacher, I have to know everything, I have all the answers, no one can challenge me. And that's when we close down all barriers to openness. And then what happens is a debate, like you said. And then there's no exchange of ideas, there's no exchange of anything. Then what examples are we setting for our next generation, really? So I'm not trying to go to any conclusion, but just a thought. I mean, trying everything.
Thank you, Arpan. Can anybody connect with that? Extend on it? Anybody want to sort of piggyback on those on that or other ideas here? Thank you so much.
Yeah, I would. This is Amy. I would say that teaching really shouldn't be about filling kids' heads with information. Like, you shouldn't be the person that holds all the information and you just kind of parcel it out to kids. You should be the one that teaches them how to learn. Like, teach them to get that information for themselves, and that way they can learn their whole lifetime. And you don't have to have all the information. You can learn right there with them, and you can be the one modeling how to learn.
That is, and also we think about kind of nature journaling in that context. It's all about observing, documenting, and asking our own questions from what we're seeing. It really ties into what Amy just said about kind of learning how to learn. And the kind of, do we take what an authority says because the authority said it? Is that a good strategy? All right. Yeah, thank you, Amy. Can anybody kind of piggyback on that or other ideas that you
Piggybacking what you just said about authority, when I was a kid, my mother, maybe to a lesser degree, my father always said, is it, what was the word? Reasonable authority. Because there's authority that says no, and it's strictly about not doing something or you not knowing something. And there's authority that says no, because whatever you're thinking about doing is maybe dangerous, because maybe there's more that you need to know. But they used to differentiate with me the difference between authority and reasonable authority.
What would be some ways that they would kind of help you parse that out? I really like that idea.
My mother always just figured I would know it. No, she just would explain that there are people out there who tell you no, and it's dogmatic and no. And then there are people who understand that you're another human being. They see your humanity. And so when they are giving you their authority in a situation, it's because they're passing along their guidance, maybe their knowledge because they're older, maybe their guidance because they have more authority and more power in a certain situation. But it's not based on, I'm the boss, you're not the boss. It's based on a more equal and fluid relationship. My mother was always reasonable authority. My father, sometimes not so much.
So a question to you or Amy, how do you as a learner feel when you come up against those two different sort of encounters with authority?
Depending on the situation, I tend to disregard, at least to some degree. I mean, certain things you can't disregard. You know, if the police officer is giving you a ticket for something, you can't really disregard. But on the other hand, if I'm talking to, 3 or 4 people and one of them is just, no, 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 I tend to say, I hate to say it, but I discount that person's opinion. I deal with the people who are reasonable authority, who say, well, I think because of this, or this is the evidence here. And so that's how I tend to deal with it. I discount as much of the unreasonable authority as I can.
So either find reasons to discount it or to sort of circumnavigate it.
Exactly.
Yeah.
Exactly.
Amy, your thought?
Yeah, what I've found with a lot of scientists, that it seems like the ones that are generally out there seeking knowledge tend to realize that there's so much more to know about a topic, no matter how much they've learned about it. And the people that are out there saying, this is how things are, those are the ones that, in my experience, have been the ones that have been trying to cover up their lack of knowledge about it. Maybe like an internal feeling that they're just not adequate enough. They're the ones that put more authority into what they say. And the ones that seem to know more about a topic, in my experience, seem to be the ones that are more humble about it, more like, well, this is what I've observed, certainly there's more out there to know about this.
That sort of makes me think about the importance then of just
So when I hear someone speaking with authority on a topic, when I hear someone speaking with a lot of authority on something, I'm like, I wonder how much they know about what they're saying.
Interesting. It just sort of makes me think of just about the importance of transparency in our teaching and our parenting. That this idea of, because I said so, we know how we respond to that, and it's the same is true when we're teaching about science. We don't want it to be, if we're teaching science from a place of authority, and that this is true because I said so, as opposed to science from somebody who is revealing the evidence behind a statement and the thinking behind an idea. Those are really different things. I know that I've been in science classes where you sort of felt like there's all this information coming out. You're like, learn this, memorize this, memorize this, memorize this. It used to be that, the person who's good at science was the person who could memorize as many of the facts that we've got. And then that person, they do well on the test. But the reason the next generation science standards were developed is because those people who were good at science, that is, good at passing the science tests, we would get those people into situations where we are now having to do science, and people are having to perform to kind of work as science, and they would fail. They couldn't do it. They could do the test of a pile of the information. So so it used to be that science was just this big pile of facts that you needed to memorize. So in your class, you memorize those things, but that didn't make for scientists. Well, that's just kind of taking a look at some of the fruits of the scientific process and endeavor. The next generation science standards, I think of it as sort of being a sort of a three-legged stool. One of those legs is, there is some stuff that we've been able to figure out through this process that is really useful to us, and we don't all have to kind of relearn it from the ground up and discover it for ourselves. So there are still some science facts that are useful to kind of get. So that's 1/3 of it. The second leg of that stool is, so that is, the first leg is, what do scientists know? The second leg of the stool is, what do scientists do? Right, so the actions of a scientist. So that can be making arguments from evidence. That can be asking questions. That can be using mathematics in your reasoning. That can be, you know, those sorts of big ideas. So 1/3 of it now is those science and engineering processes. And the other leg is, how do scientists think? How do we kind of take all these disparate ideas, how do we pull those together under the umbrella of big picture ideas that help us make sense out of this, kind of the structure of the tree, as opposed to the details of all the little leaves. If you just sort of learn all the little leaves, you don't have the structure of the tree. So that's what they call, so you've got the science and engineering practices, you have the disciplinary core ideas, those are the things we've learned, and you have what they call the cross-cutting concepts, which is the structure of the tree. So now in science class, those three things are being integrated. If you are a homeschool parent and you are looking at how you want to teach science in with your family, I really recommend that and one of the nice things about being a homeschool parent is you're not bound by any of these of the standards that nobody's saying, like, do this, but these are ones that I actually recommend you sit down with them and take a close look at it, because it took them about a decade of working with the National Academy of Sciences, National Institute for Engineering, and National Academy of Medicine. They all, and educators, and this is what they came up with. And me as a scientist, I find it really useful. It's a useful way of thinking. A lot of the ideas that we're talking about in here, in this conversation, fall under that umbrella. So it's useful to check out. Also, if you're in a different country that doesn't have the next generation science standards, these are worth you checking out. Similarly, if you are in a non-NGSS adopting state, some states in the United States of America have not adopted these. In those cases, if you have any flexibility in how you're doing stuff in your classroom, I really recommend that you check those out. And they're very, very useful. And also the book on how to teach nature journaling that Emily Ligren and I wrote, that makes very clear connections to the, we say sort of how we are kind of integrating those ideas of the next generation science standards. I'm not a booster of like every set of standards that kind of rolls around, but these NGSS ones, I like them, especially the cross-cutting concepts and the science and engineering practices. Those are really useful. Ray Bonto has got a copy of How to Teach Nature Journaling right there. Hey, thanks for popping that up.
I had to get it for him. He's driving me crazy for not getting this book.
Well, I mean, I'm still not satisfied. I still want all of your books, probably, still. So I got one of them, and I wanted another one, and then I wanted this.
So he's going it.
That's fantastic. Ray, I'm curious, have you had a chance to look through any of it yet? And are there parts of that you found really interesting?
Oh, yeah, it was quite interesting. Yes, it was. Well,
I think he hasn't had a very good look at it yet. It just came in yesterday, yesterday afternoon.
Day before.
Yeah, so
Oh, great.
he's still with it. The moment he wakes up, it's one of your books, and the time your books have become bedtime stories as well. So
Yes.
yeah.
Oh, that's fantastic. I'm really glad that you are looking at that. You can sort of, in that, you can understand a lot of the thinking that is behind what we do when we're doing nature journaling. Why is it we're doing that in that way?
Yeah.
Yes.
Thanks, Jack. Lovely book, lovely resource.
Thank you so much. Oh, and so I just want just a little fashion show here. Take a look at Amy. Is it all right if I
Go ahead.
let's spotlight you right here.
My daughter says she loves your t-shirt.
Ah, excellent. I like your fashion choice. I like your fashion choice.
Thank you.
It's really good to see you. Thank you. So my dear friends, this has been really fun, really interesting. I actually had a bunch of journal articles kind of queued up that I thought would make for an interesting discussion. But the minute we got on, things took an even more interesting direction. These nature journal workshops, each time, these nature journal educator workshops, each time we're going to be grappling with some different ideas. I hope that this was really useful to you. I want to recommend that people, if you go to the chat box, you can save the chat. You see where it says save chat? On the bottom, there's a little ellipsis, those three little dots. Click on that, a little option there at the top says save chat. If you want to see those, to get those references and ideas that go along with our conversation here, want to encourage you to join us each week for more of these discussions where we'll take some aspect of being a nature journaling educator, science educator, communicator, and what we can do to be more intentional about our practice. We're in the search for the best practices in this newly emerging area, and I find it's a lot of fun. Thank you folks so much for your participation and joining us today.
Thank you, Jack.
Thanks, Jack. Thanks, everyone.
Thank you, Jack. It was wonderful.
Thank you, sir.
Thank you. It was good to see everybody.
Thanks, everybody.
Everybody stay safe, especially in the afternoon if you're in California. Stay safe with the fires and with the smoke. Okay, take care, everybody.
Be well, be safe. Thank you, my friends.